This morning you turned a key or pushed a button, and a machine that weighs 2 tons woke up instantly. You didn't think about it. Nobody does. But the thing that actually did it, the thing that delivered the jolt of power to start your car, was a slab of the heaviest, softest, most poisonous metal we still pull out of the earth by the millions of tons: lead. Right now there's probably 40 pounds of it sitting in your garage. And here's the strange part. The lead in that battery is older than the dinosaurs. It will outlive you, your children, and everyone you will ever meet. We have been making it the same basic way for 8,000 years, and in all that time, almost none of it has ever truly gone away. So how do you take a dull gray rock out of the ground and turn it into the metal that runs the modern world? And why, once you've made it, can you never get rid of it? The answer runs from a billion-year-old crystal through a river of fire to the most successful recycling story on the planet. And it changes how you think about waste, about value, and about the invisible machinery holding up your ordinary life. Let's start with the rock, because everything begins with the rock. The ore is called Galena, lead sulfide. If you saw a chunk of it, you'd stop walking. It grows in perfect metallic cubes, mirror bright, impossibly heavy for its size. Pliny the Elder described it almost 2,000 years ago in the year 77 in his great encyclopedia of the natural world. Humans have been chasing this mineral since before we could write. It was one of the very first metals we ever learned to smelt, more than 8,000 years ago, before bronze, before iron. And Galena is dense with promise. Almost 87% of it by weight is pure lead. That's why men have lost their minds over it. In the 1820s, a Galena rush hit the American Midwest, and a little town in Illinois swelled so fast on the back of this rock that for a moment it rivaled Chicago. The town's name, fittingly, was Galena. But the crystal in the ground formed long before any of that. Deep underground, sometimes more than 1 billion years ago, hot, mineral-rich water cooled in the cracks of the rock and left this metal behind. When a miner's drill finally reaches it, they're touching something that has been waiting in the dark since before complex life existed. Now you have to get the lead out. And the first step is one of the most beautiful tricks in all of industry. You crush the ore. Not into gravel, into powder, finer than flour. And here's the problem. In that powder, the precious galena is mixed with tons of worthless rock. So how do you separate them? You'd think you'd use the weight. Lead is heavy. Just let it sink. They do the opposite. They make the lead float. It's called froth flotation. You dump the powder into water, add a few carefully chosen chemicals, and blow air up through the tank. The chemicals make the surface of the galena hate water and love the air bubbles. So the heaviest mineral in the mix grabs onto the bubbles and rides them to the surface, gathering in a gray metallic foam, while the worthless rock, the stuff you don't want, sinks to the bottom. You skim the froth off the top like cream. You've just turned ore that might be only a few percent lead into a concentrate that's 60, 70, 80% lead, with bubbles. But it's still not metal. It's still a chemical compound, lead locked to sulfur. To break that bond, you need fire, a lot of fire. First, they roast it. The concentrate is heated on a moving grate until the sulfur burns away as gas, and the lead turns to a crumbly oxide, a hard, porous cake called sinter. Then that sinter goes into the throat of a blast furnace, layered with coke, a nearly pure form of carbon. They blast superheated air into the bottom. The coke ignites, and inside that furnace, the temperature climbs past 1,000 degrees. The carbon rips the oxygen away from the lead, and finally, after 8,000 years of human effort, after the crushing and the floating and the roasting, pure liquid metal pools at the bottom of the furnace. They tap it like a keg. Molten lead, the color of dirty silver, running out in a glowing stream. This raw metal has a name, lead bullion, and it is hiding a secret. Because here's what's fascinating. That dull, cheap, heavy lead almost always comes out of the ground carrying a passenger, silver. Tiny amounts scattered through the metal. Too little to see, but worth a fortune in bulk. And for centuries, nobody could get it out efficiently. Until 1850, when a British metallurgist named Alexander Parkes figured out something clever. He found that if you stir a little molten zinc into the molten lead, the silver abandons the lead and rushes into the zinc. It's not picky preference, it's chemistry. Silver is about 3,000 times more soluble in zinc than in lead. The zinc, carrying the silver with it, floats to the top as a crust. You skim it off, and you've stolen the treasure out of the trash. To this day, a huge share of the world's silver is not mined as silver at all. It's a byproduct, a happy accident of making something as humble as lead. What's left, after the silver is gone and the last impurities are skimmed and burned away, is lead so pure it's over 99.9% metal. They cast it into ingots, stack it, and ship it. And then it gets its final shape. Mixed with a pinch of other metals to make it strong, pressed into thin plates, stacked with acid between them, sealed in a plastic case. The raw materials have become the final package, around 40 pounds of refined ancient rock, sitting under the hood of your car, ready to start your morning. The line is finished. Rock to metal to product. Except, and this is the part nobody tells you, the line doesn't end. It was never a line at all. Because lead has a dark twin to its usefulness. The very things that make it perfect, soft, dense, stable, unchanging, mean it does not break down. Ever. It doesn't rust into nothing. It doesn't rot. It just stays. And in the 20th century, that turned into a catastrophe. In 1921, on December 9th, a chemist named Thomas Midgley Jr. dripped a lead compound into an engine and watched a problem disappear. Engine knock, gone. The compound was tetraethyl lead, and within a few years it was in gasoline all over the world. We were now burning lead and breathing the exhaust. We had taken the metal that never goes away and sprayed it into the open air of the entire planet. It took one stubborn scientist to notice. In the 1950s, a Caltech geochemist named Clair Patterson was trying to do something completely unrelated. Measure the true age of the Earth using lead isotopes. He got his answer, 4.55 billion years, the number we still use today. But to get it, he had to build some of the world's first ultra-clean laboratories, because he kept finding lead contaminating everything. It was everywhere. And in 1965, he published a paper showing the truth. The average modern human was carrying something like 100 times more lead in their body than our ancestors did before the industrial age. It wasn't natural. It was us. Patterson spent the rest of his career fighting to get the lead back out of our gasoline, our food, and our blood. And that lead we burned, it's still here. In the soil, in the dust, it never left, because lead never leaves. But here's the redemption, and it's the strangest twist of all. We took that permanence, the thing that made lead a curse, and turned it into the most successful recycling system humanity has ever built. A lead battery, at the end of its life, is almost never thrown away. In the United States, 99% of them are recycled. It is the single most recycled consumer product in the country. More than paper, more than glass, more than aluminum cans. Roughly half of all the new lead made in the world isn't mined at all. It's old lead, melted down and born again, using a third of the energy it takes to make it from scratch. So think about what that means for the battery in your car. The lead inside it almost certainly isn't new. It was probably a battery before. And before that, maybe a battery again. It may have been a pipe in a Roman bath, a musket ball, a stained glass window, a fishing weight, the very gasoline that poisoned Clair Patterson's clean rooms. The same atoms, melted and reshaped and sent back out over and over for thousands of years. There is no final package. There never was. We don't really make lead. We just borrow it and pass it on. So tomorrow morning, when you turn the key and the engine catches without a thought, remember what's actually down there. Metal older than the dinosaurs, pulled from a billion-year-old crystal, floated on bubbles, born in fire, stripped of its silver, poured into a shape that will not last, wrapped around atoms that absolutely will. You're not driving on a battery. You're driving on something close to forever.